The overall goal of this method is to evaluate the suitability of implants for magnetic resonance imaging or estimate the vulnerability of pulse sequences to metal artifacts.
This method can help to answer key questions in the radiology field, such as the evaluation of MRI suitability of implants and the estimation of vulnerability of pulse sequences from metal artifacts. The main advantage of this methodology is that it allows for a three-dimensional artifact evaluation in fat-suppressed and not fat-suppressed T1 and T2 weightings at the same time.
The implications of this technique extend toward diagnosis of peri-implant diseases because it allows for optimization of MRI protocols with regard to reduction of peri-implant artifacts.
Before constructing the phantom for this protocol, first determine the volume of the implant to be studied. Here, water displacement method is used, and the volume of the samples measured 0.65 milliliters and 0.73 milliliters respectively. Select a non-ferromagnetic plastic waterproof box that is larger than the expected MRI artifacts. Then fix the implant position in the middle of the box using a thin thread. Next, carefully melt a mixture of semi-synthetic fat, water, and macrogol 8 stearate using a water bath at 50 degrees Celsius. Here, a 500 milliliter mixture was used for the embedding of each sample. Once the mixture becomes fluid, turn off the heat and then start stirring it slowly. While doing this, ensure that there is no separation of the fat and water phases in the mixture. Then, as soon as clotting begins, slowly pour the embedding.